Physics has been in this world for centuries. Starting with astronomy, physics enabled humans to discover and prove countless phenomenons and theories. It is until today, the most accurate empirical evidence out there. In the 1880s, a new name started coming out, and that was the physicist Albert Michelson. Him and his friend Morley, a chemist, did a series of experiments that had a great impact. They ignored something that most people believed in: the ether effect, which is an ether that facilitated the movement of light through space. Michelson's parents could not afford sending him to college, so he worked at the White House, which brought him closer to the President of the U.S. The President secured him a free place at the U.S. Naval Academy, where he learned physics. 10 years later, Michelson is a professor at K School in Cleveland. He experimented on something called the ether drift, which required to measure light. He did that by measuring light as the Earth moved away and to the Sun. Michelson contacted scientist Alexander Graham Bell, inventor of the telephone, to build a device that Michelson had thought of by himself called the interferometer that would be able to measure light. The results showed that the velocity of light did not change, which made people uncomfortable with that idea, since everyone thought that the velocity of light changes over time. At this point, Michelson won the first American Nobel Prize for Physics. This realization confused scientists. Everything they knew became questionable. A shift took place from macrophysics to microphysics. In other words, quantum physics, which is when energy is not a continuous flow, but is small individual packages called quanta. That is where Max Planck steps in the picture with his quantum theory. Planck was a German physicist who won the Nobel Prize in 1918 for quantum theory. In 1900, Planck was a 42-year-old professor at University of Berlin when he came up with the quantum theory. This theory helped solve the puzzle of how light cannot be a wave. On the long run, the theory became the basis for modern physics. However, a breakthrough happened when in 1905 a third-class examiner with no university affiliation or special equipment published 3 life-changing papers. The first one explained nature of light, the second one proved the much-debated existence of atoms, and the third outlined the special theory of relativity, which changed the world. His name was Albert Einstein. Einstein was born in 1879 in southern Germany and grew up in Munich. He learned to speak when he was 3 and failed college entrance exams. He chose to give up his German citizenship in order to avoid military conscription. He ended up in Zurich Polytechnic Institute. He was bright but not outstanding. He graduated in 1900 and began publishing papers right away. His work engaged and stimulated him to write the special theory of relativity. On the electrodynamics of moving bodies is considered one of the most extraordinary scientific papers ever published because Einstein came up with it all by himself. A few months later, he published a supplemental paper with a new notion: E equals mc2. Nobody really knows where c, which stands for the velocity of light, came from. Einstein just decided to use it. This formula showed that there's a huge amount of energy bound in every or any material thing. This gave rise to the idea of the atomic bomb. Einstein gave a whole new explanation to the universe, where light is supreme and there is no ether effect. Einstein got rejected several times and went back to working as an examiner. But this did not stop him from thinking more. In 1907, a publication of a paper entitled Cosmological Considerations on the General Theory of Relativity was published. This theory was more brilliant than the special theory of relativity because it required a lot of ingenuity that no one would likely ever come up with. Because the general theory of relativity was so non-intuitive, it was said that only 3 people in the world understood it. The theory explained that space is a 4-dimensional fabric, with that 4th dimension being time, which is deeply embedded into the fabric. It explained that gravity is the bending or indentation of that space-time fabric. Gravity, therefore, is an outcome, not a force.
Created using Powtoon.